Okay, the question is in an equilateral triangle ABC, point D lies on a side BC such that BD is one third of BC. Analyze the side segment configuration to prove that 9AD square is equals to 7AB square, right? So first of all, I will take a triangle, equilateral triangle ABC, and what is given that BD is one third of BC, and what I have to prove that 9AD square equals to 7 of AB square, right? Okay, I have to do one little construction. Why? Because see, I have to prove AD square and AB square. So square, how can I introduce the square in my equation? I can use the Pythagoras theorem and the similar triangles. Like cross multiplying the square can become right. So here I will use the Pythagoras theorem. So for that Pythagoras theorem, I need a rectangle, right angle triangle, not rectangle, sorry, the right angle triangle. So can I make a altitude AE from A on BC? So AE is your right angle triangle, right? So I will take, so in construction, I will write take altitude AE on BC, right? Okay, and one more thing, BE will be equals to EC. Why? You can prove that BE is equal to EC in this using the congruency of a triangle, the triangle ABE and ACE. By which congruency you can prove, like you can prove by RHS, right angle, hypotenuse same, and one side AE is also same. So by CPCT, corresponding parts of congruent triangles, you can say na BE is equal to EC. So this is one of the important property that altitude in an equilateral triangle will act as a median as well. Like it will be dividing the base as well, right? Okay, we'll start with the proof. So in triangle, I'll take the triangle ADE because I want AD in my final answer. AB I can introduce. So in triangle ADE, apply the Pythagoras. So I can write AD square is equals to AE square plus DE square, right? And can I write the DE as DE is equals to BE minus BD? BE minus BD will be your DE. So at the place of DE, I will use this equation. So I can write AD square equals to AE square plus of BE minus BD whole square, right? So AD square equals to AE square plus, okay, BE. BE is half of BC because as I told you, E is the midpoint of BC. The BE is equal to EC. So BE I can write it as half of BC. So BC by 2 minus, how can I write the BD as? BD can be written as BC by 3 whole square. Okay. So AD square will be equals to AE square plus, subtract these two, 6, 3 minus 2, 1. So BC by 6 whole square, right? Okay. So from here, I will get AD square is equals to AE square plus BC square by 36, right? Okay. I will do this question by taking the x as well. Okay. See, if I'm taking a triangle, in this triangle only, this is equilateral triangle. So this is x, A, B, and C, and this is your E. So if this is x, BE will be x by 2, and EC will also be x by 2, right? So by Pythagoras theorem, can I find the AE? See, AE square will be AB square minus BE square. So AE square will be x square minus x square by 4. That is your 3x square by 4. And AE square is this now. So AE will be come out to be root 3x by 2, right? the AE value. So I'm gonna use this thing. So AD square will be, okay, AE square is 3x square by 4 plus BC is what? BC is also a side of equilateral triangle. I can write it as x square by 36. Take the LCM, 36, 9, 27 x square plus x square. It will be 28 x square by 36. That's the value of AD square, right? So AD square is 28 by 36. I can simplify it. 4 sevens are 28, 4 nines are 36. So AD square is equals to 7 by 9 x square. And what is x square? Can I write x square as AB? Because that is also the side. AB I took as x only, na? So I will get, this will give me AD square is equals to 7 by 9 AB square. Now cross multiply, I will get 9 of AD square is equals to 7 times AB square, right? Okay, so that will be all. Thank you.